Cool. So we were discussing about, so the baseline and the other stuff, right? The configuration stuff, right? So whenever we work on any performance issue, so we should have some baseline, right? So anything you can consider like CPU utilization. So CPU utilization, high CPU issue, right? So even if it is high CPU utilization issue, so we'll have to understand the baseline of so the CPU spike, right? For example, like today it's 90%, right? What is the ideal so CPU utilization on the server, right? So it can be either 30%, it can be either 10% or even 90% consistently, even in the even in the past. So that is the baseline that we should have, right? So without any baseline, without any proper baseline, so we should not be able to find, or we should not be able to find and tune further, right? So that's what we were discussing. We should have a baseline now. So whenever you can consider, let's take an example like the query is running slow, right? So when the query is running slow, sorry. Okay, so this we know, the simply so wait like suppose if the query is running, if the thread is running on the CPU, we call it as a runtime, right? So we call it as a runtime. If it is not on the CPU, so we all call it as a wait time, right? So this is all called as a wait time. If the thread is running on the CPU, right? So this is currently on the CPU, then it is a CPU runtime. So if the thread is not in the CPU, either it could be in a runnable queue, it could be either in a waiter list, it could be either in the so blocked, suspended, whatever it is, we call it as a running waiter thread, right? So this is what it is, actual execution time. So actual execution time is the time which the thread is actually so spend time on the CPU, right? So if the thread is spending time on the CPU, is called as the actual run time or execution time. Let's say for example the query is running slow. If query is running slow, we should have a baseline, right? What our baseline? 10 minutes. Now query is running 30 minutes or even 1 hour. If that is the case, so what we will have to check? So first thing, mostly we will have to check whether either the query is a running query or a waiting query, right? So suppose if it is a running query, the time, whatever 1 hour or 30 minutes, whatever it is completely spent on the CPU. If the thread is waiting query, then it is waiting for some resources. Either it could be in the runnable queue, waiting for CPU to be available, or it can be in the waiter list, waiting for some resource to be available, right? So that is what we'll have to identify. I'll show you how to check that. All right, so here the run versus wait. Query worker thread. So if it is a run, if it is spending on the CPU, then it can be either the query is executing or it is compiling the query, right? So in both situations, we require CPU to be available and it is running on the CPU. Even compilation, right? Query optimizer compile the query. So query optimizer compile and generates an execution plan that also requires some CPU cycles. That also needs some CPU cycles, right? So in these two requires CPU cycle, whereas if the thread is waiting for any resources, that is what we call it as a wait for some resources. Either it can be one of these, not limited to these. So it can be, so any resources that we can consider, right? If it is not either executing or compilation, if it is the thread is not spending time on these two, we call it as a waiter. That's it. So either it can be a lock, that is what you call it as a blocking lock, block, deadlock, whatever it is, and it is waiting for IO, right? So I will that we will talk like what are the wait types, and it is waiting for some network. It is waiting for memory, it is waiting for latch and other. So it is not actually running on the CPU, right? So it is waiting for some resources to be available. Right. So now wait statistics. Let's understand like few DMVs that we have to find the weight information, or to find the weight statistics details, right? So what DMVs that we have? Select star from sys.dm underscore os underscore weight task. Select star from sys.dm underscore os waiting task. Sorry, os wait stats. Okay, so sys.dm underscore os wait stats and sys.dm underscore os waiting task. What it does, right? So this give the overall aggregated wait types since the SQL service restarted. Right? What does it mean? Historical waits. Since the SQL restarted, you will have that information in the sys.dm underscore os wait stats. So this is the overall weights of that particular weight type or weight resource. This one, the current waiting task, right? So this is currently giving what the sessions waiting on what wait type, right? The current execution wait types, right? So if you execute this, this is the session details and what it is waiting for. And so what is the wait duration that each session is waiting wait time on this particular wait resource, right? So that is how you can find the sister dm underscore os waiting tasks, right? So what task waiting on what wait type, what are all tasks waiting for the wait types that we have. Okay, so this sys.dm underscore os wait stats, it gives that aggregated or consolidated weights from the time the SQL service restarted, right? So since the SQL restarted, you will see the weight types. I mean the OS weight stats. Let me show you here. Okay, so this is the historical, so historical weights from the time SQL restarts, right? This is we are pulling from the sys.dm underscore os wait stats. What is that? Sys.dm underscore os wait stats. Okay, so we are pulling from here with the remaining okay, so sys.dm underscore os wait stats is the DMV which we pull, right? So if I execute this, so this we will have the wait time, wait type that we have, and what is the wait count, right? How many times it executes and how many times, so the wait that it captures this wait type, and what is the total wait time, right? So what is the total wait time and average wait time and signal wait time? So we have to calculate. So what is the total resource wait time and what is the percentage? So that you will have to calculate and understand what is the total percentage the queries are waiting for, right? So I can share these queries in a Git repo, or so I will upload this details into Git repo and will share with you. But here you can identify what are all top weight types that we have, right? So I will tell you what these columns are, just bear with me, right? So you can identify the top weight types that we have, right? So which is contributing most of the time in percentage. Okay, I will tell you. Okay, so wait time. So what is the wait time that we have? So wait time is nothing but the total time it is waiting for some resources, right? So what is the wait time? Wait time is total wait time. It is waiting for some resources, right? Cumulative wait time since the service or server restarted. That is what I was talking, right? So what is the total and cumulated wait time? Okay, so wait time is the total, so wait time is the thread. How much time a thread is waiting for some resources, cumulative wait time, and total time the thread is waiting since the service is restarted, right? So signal wait time. So signal wait time. So we all know, right? Like I was talking about, so the thread scheduling, right? How thread will be scheduled. Like currently one thread is running on the CPU, right? So CPU and the other thread is in the runnable queue. Okay. So it is in a runnable queue, a thread. So when this thread will execute, so the current thread will have to give a signal to the thread which is in the runnable queue, so that the runnable queue thread will go ahead and execute on the CPU, right? So the signaling will be given by the thread which is currently running on the CPU, right? So this is one of the important things that you'll have to note or notice, right? So signal wait time. Suppose let's say you see a wait time as SOS scheduler yield, right? SOS scheduler yield, you might have seen. SOS scheduler is nothing but SQL operating system waiting to schedule the thread. When that thread will be scheduled, once it receives a signal from the thread which is currently running on the CPU, right? So the thread which is currently running on the CPU has to give signal to the thread which is available in the runnable queue, so that the thread will go ahead and execute on the CPU. So until and unless the thread receives a signal from the thread which is running on the CPU, will be waiting and marking as SOS scheduler yield. The thread in the runnable queue will be waiting and so marking as SOS scheduler yield. Until and unless it receives a signal, the thread will not be executed. So the question, can I consider so all SOS scheduler yield as an issue? That is what you'll have to look here in the signal wait time. Suppose if you see or if you notice the signal wait time is more, right? So then it is considered as it is waiting for the thread to be given signal to the thread which is in the runnable queue, right? So that is signal wait time, waiting for CPU cycle to execute, right? So total wait time, right? So this is the total wait time is nothing but wait time and signal wait time, right? So wait time is nothing but a thread is waiting for resources that is in the where? So that is in the non-runnable list. Let's say we have two lists. Let's take some example, some scenario. We have two lists. One is runnable, another one is some IO list or some waiter list. Okay, so here this is your CPU. This is your CPU. Okay, so thread is running currently. Thread 1 is currently running, right? So here thread 2 is in runnable queue, some thread 3 is in runnable queue, and thread 4 is in waiter queue, right? So now the total wait time is nothing but the thread is waiting on the waiter list. right? So the thread is currently on the waiter list, right? How much time it is waiting for some resources, either it is a lock, or it can be either some resource, or can be memory, can be CPU, whatever it is. So it is waiting on the CPU, right? Some wait resources. What is the time it is spending on the wait, right? Now in the runnable signal wait time, signal wait time, a thread which is currently, this is your T4 wait. Okay, signal wait time is the currently thread in the runnable queue and available for so it has all the resources it requires and ready to run on the CPU. If it is ready to run on the CPU, but another thread is currently running on the CPU, in that case it has to wait, that is T2 and T3 has to wait T1 to give a signal, right? So signal wait time T1 to T2, the first thread in the runnable queue. So it has to wait, right? So signal wait time is the amount of time it is waiting to get a signal from the thread which is currently running, right? So these two, wait time plus signal wait time, is called as a total wait time. Total wait time, how much time the thread is actually waiting so to execute the query, right? So let's say for example 10 minutes or 31 hour, let's say for example 1 hour a query is 1 hour a query is executing. So in this 1 hour, right? So in this 1 hour, if you notice that 50 minutes is waiting, let's say for example 50 minutes is waiting and 10 minutes is running actually, that is your runtime, right? So execution time. So 10 minutes is running and 50 minutes is waiting, then we consider it as a waiting query, not the running query. So we will have to identify and troubleshoot these wait types, then troubleshooting the individual query, right? If the query is waiting most of the time, then we consider it as a waiting query. If the query is running and spending most of the time on CPU, then we consider it as a running query, right?
Excuse me.
Yes.
So I have a question on the SOS Yates, which type.
Mhm.
So in what scenario will you know that we know SOS Yates which type is normal, but we know that SOS
Correct. Correct. So that's what we will talk that in the so common wait type scenarios. But SYS scheduler yield, I was mentioning, right? Suppose if the SYS scheduler yield is common wait type,
abnormal?
but if you see the total signal wait time, right? So signal wait type wait time is very high. For the SY. Signal wait time is only for the SY scheduler yield. If you notice that SY scheduler yield, and if you see that signal wait time is high, then that is what you will have to consider looking into that. Right? For example, if you see that average signal wait time, and in this average signal wait time, you see a significant value or even more, right? So 10%, 15%, whatever it is, and that is what it is considerable. So you will have to consider if the signal time is more. So in that case a thread is waiting most of the time in the runnable queue and waiting for the thread in the thread which is running in the CPU is signal to the thread in the runnable queue. So the wait type is like, so you'll have to check what is the what is the signal wait time, so that you will understand whether it is noticeable or not. If it is signal wait time is 0, so then thread is in the runnable queue and immediately it will go and execute on the CPU.
So what about this? No, this one that you are showing us now. The average signature wait time is 0.0, but the percentage say 49%. Do we need to consider that percentage as well?
Percentage you'll have to consider, yes. So percentage you'll have to consider. So it is not so waiting on right. So okay, this percentage is calculated based on the wait time and the signal wait time. So I'll show you that. So wait time in milliseconds, and this is the total wait time. Like, so how much is the wait time that it is? Uh, 1 second. So how much is the wait time? What is the percentage of wait time? It is currently spend most of the time on, right? So this wait time, this wait this is the total wait time. So total wait time is including the signal wait time and the wait time. It is wait time, right? So signal wait time and wait time both are two things, right? Wait time is nothing but waiting for some resources. If it is wait time is more, that is your total wait time, not total, uh, resource wait time is more, then it is not waiting on SOS scheduler yield. It is waiting for some resources. Either it could be a lock or it could be block, whatever it is. Here in this case, it is XA dispatcher wait. This percentage you'll have to wait, you'll have to think, like suppose if you see that SOS scheduler yield and you see the percentage, definitely it is considerable. If it is SOS scheduler yield, definitely you will have signal wait time, not the resource wait time. Because SOS scheduler yield, it is waiting for thread to be signal which is running on the runnable queue. So that wait time will be changed and you will see the signal wait time. So percentage should be so considerable. That is what we calculated. Percentage, if most of the percentage, right? So 49% is waiting for some resources is not optimal. It is not ideal, right? So in the same way, if it is more than 15-20%, it is waiting for some resources. That is what we need to understand, why it is waiting for 15-20% is out of the total execution. Yep, you will have to consider that way a percentage as well.
Hello, Chandu.
Yes.
Yeah, Chandu, for this, we need to concentrate on the signal wait time plus percentage, right?
So this is the total wait percentage.
Yeah, okay. If it is in SOS,
Hmm.
so the average signal wait time will be more, right?
Average signal wait time will be more. Yes.
So at that time, we need to concentrate on the which query is taking more time.
Correct.
Okay. Okay,
Yeah.
Chandu, thank you.
Which query is running most of the time on the CPU, that we will have to consider.
Okay, thank
Or
you.
if there is any issues with the actual CPU, so that we have on the server. Let's say, for example, 4 CPUs I have. So if I have 4 CPUs, 1, 2, 3, 4, right? So if I have 4 CPUs and all CPUs are busy, and so which doesn't have any I mean, all CPUs are busy, and whereas in the runnable queue, so the threads are waiting for these queries to come out of CPU, right? So in either case, so either it can be a CPU intensive or it can be a query which is running slow. So we'll have to look at the queries which are currently running on the CPU and taking most of the time.
Oh, thank you, Chandu.
Sure. So we will talk that, and we'll also talk that weight types that we need, that we have. So here, that is just it is calculating. So based on the values that we have, right? So wait time minus signal wait time as resource wait time. So if you see that resource wait time is the total wait time of the resource that we have. This is the resource wait time, right? So this is the total wait time of the resource excluding signal wait time, right? So this is the resource wait time, average resource wait time and percentage that is calculated. Percentage sum, right? So this is the aggregated wait time and over, okay, divided by wait time in milliseconds and running. Okay, so any questions here around? Okay, so the wait time plus signal wait time is called a total wait time of the resource that we'll have to consider, and dm is that I was talking, right? So sys.dm underscore os waiting task, right? Suppose if you want to troubleshoot, if you want to perform a live troubleshooting, so we can use the sys.dm underscore os waiting task. Whereas if you want to postmortem or debugging the issue, you can use the sys.dm underscore os wait stats, right? So this gives that historical weights starting from historical weights since the SQL has restarted. So since the SQL has restarted, we get sys.dm underscore wait stats, right? And track cumulative and total, right? So it gives that total and cumulative information of the wait time that it is waiting for, right? So normally we have this wait times, right? A type wait types which the thread are waiting for. Now, can anyone tell me like what are all wait types that you are aware and you have worked on, right? So let's say like you might have worked on few or you might have noticed few, right? So what are all wait types that you have noticed in your day-to-day so life, so that maybe I feel like you are aware of some wait types and
That's
one
that's
line.
that's OSO yield is very common.
Which one? SOS?
Yes, SOS yield is very
Okay.
common with them.
Okay.
And most time to CS package.
Okay.
And I think I used to get a lot of page highlights as well sometimes.
Reliable latch. Okay.
Then sync network IO.
Sync network, async network IO. Okay. Okay.
I
So any
think
other
resort something resort semaphore wait or something.
LCK.
lock?
Yep.
Okay. Good. So what else that you know? Nothing? You don't see anything?
Um, there are a lot of them.
Hmm.
I think there's another one that they
Anything
call
makes sense.
wait delay or something.
Wait
I
for
think I
delay.
used to see that. I
Um,
think it's wait for delay or something. I used to see that.
yeah, but yeah, that all depends, right? So wait
Okay.
for delay, like so if you specify like wait for delay in your code, so maybe that is waiting for that wait for delay until that time specified. So anything specific that resource, right? So normally if you go here sys.dm underscore os wait stats. So these are all weights, right? So maybe there are so few which are relevant, like for example lock to lock, right? So until this it is relevant, right? So likewise,
Mm,
like whatever different locks that we have, so latch, this is relevant. So
mm,
likewise, so you have many here, right? So resource semaphore query compile, HDR sync commit, right? So you have many things so to be noticeable, right? So few no need to worry, like for example if it is so HDR. So memory grants update, resource semaphore, resource file handle. So I never see these weight types, but yeah. So if you would see one of these weight types, right? So here, so if you're doing any of the IO operations which requires a so storage level access, right? So for example, internal things, right? So for example, it has to do some IO operation, right? So this preemptive OS related weight types you might notice, right? Some internal IO, internal as in IO async related IO operations performed by the SQL server. Then we see that, right? So there are many weight types which even I might not be aware of all these, right? So these are all might not be common or might get like, so might not get like a very frequently. So in that case, we'll have to go through and understand the weight types from the books online. But I will touch base a few which are common, and I'll tell you how to check and how to investigate the issue further.
Okay, add CS consumer to the list of the ones we're asking.
Correct.
CS consumer.
CX consumer, CX packet,
And, they are
yeah,
the same family.
same family, correct. Right. So cool. Okay, so let's take a common weight types that we have. Six consumer. Okay, cool. So common weight types, right? So these are all just so high level common weight types. So day to day we might see, right? So we might see some different weight types as well, right? So if it is waiting for some resources, suppose if it is a backup. So if it is backup IO, right? So if it is so some weight types that you might see and which you are not even aware of or not sure, maybe we can get through that, so books online, or even we have SQL skills, right? So if you are aware like SQL skills, there you can find that, so a high level definition what is that weight type is, so that you can understand that what is SQL, so what is that weight resource is, right? So that is a Paul Randall. So you can get that, so whatever the high level weight types, what exactly the weight resource and weight type it is, right? So here, so these are the common, right? So CX packet, SYS scheduler yield, this is your SQL operating system, if you remember, right? So thread pool, right? So we will talk that all this in so high level. So lock, LCK, so it can be either lock, exclusive, shared, update, whatever it is, and page latch or page IO latch. I have not mentioned that all the latches that we have: page latch, page IO latch, and the latch weight types that we see, and write log, and HRDS sync commit, and resource semaphore query compile. So majority of them I noticed, right? So majority of them I noticed in my day to day, right? So if you have anything specific want to understand, so we can talk. But here, these are the things which I noticed, or which we usually notice during our investigation or performance issues, right? Let's say, what is this six packet? What is this CX packet? So CX packet is nothing but a query thread is running parallelly and waiting for some resources, right? So let's say how this works. My system is slow. Okay, how that works. Let's say I have I'm gonna execute one query, right? It can be either select star from table, okay, where ID equal to 100, whatever it is. And this has to be executed parallelly. This has to execute parallelly. Can anyone tell me? So as soon as I have a parallelism enabled, right? So what do you mean parallelism enabled? I have a max top is set to right 4, for example, right? Max degree of parallelism set to 4. That we will talk. Don't worry about. If you don't know, we will talk. But max degree of parallelism set to 4, for example. Now the select start from table, right? So you are executing this query. So can anyone tell me whether straight away this goes to parallel execution or no? I have a,
Where that was? What is the question?
okay. So the question is, I have a parallelism enabled. So that's what max degree of parallelism set to 4. And if I execute this query, so will it go for parallel execution, or it is a serial execution? Will it spawn multiple threads to execute this query, or only a single thread?
You say
I
select
think it
star.
will see. Yeah, I think it will be a single thread.
Single thread, why?
Yeah, single thread.
Why?
No, it will not be a single thread.
It,
If
select,
Chandu, if it is less than 5 seconds, it will go for the parallel.
Yes.
Why that 5 seconds?
because you do
because you
select
don't
star.
want to because you don't want to use the more CPUs.
How
Because
that?
you are,
Yeah.
this query is actually filtering and it's more specific. Unlike you're saying select all from the table, it means you are trying to extract all the information on the table. But this one is more direct and specific. So it
No,
will
that's
only
a
look,
killer query. Anytime you see star, it's a killer query. They will avoid
but
that.
now,
Like you can avoid star.
yeah, but you are filtering. This is a where clause, where ID equals 100. So it will streamline the search and extract the information you're
True.
trying to
True.
retrieve.
So you mean that it is a
Yes, we're close.
so it doesn't matter. Like let's say for example, whatever it is, right? So
It will not trigger.
it will
Cannot trigger.
you mean that it go for single thread?
Yeah, you do not use parallelism.
Okay. Okay, it does not use parallel execution. Select
Yes,
star
because of
from
the word clause.
because of the where class. Okay, table one. So table one A, let's say inner join table B on A dot ID equal to B dot ID. Now
Let's start from
Yeah,
this
that
is
will trigger. That will trigger.
okay. This will trigger what?
That could trigger parallelism because it's not direct.
Could as in
Yeah, it could. Like it could use parallelism. I'm
that's
not
what
too
I'm
sure.
asking. What is the definition of could, right? So could as in like it will definitely go for parallel execution or it will go for serial execution. Let's say whatever time that I'm not bothered. Like so the concept we need to understand whether you execute
Parallel.
any query, will it go for parallel execution? Because I set it to max degree of parallelism set to 4.
It will go for parallelism.
It will go for
Yeah,
parallel.
because it's getting a bit complex. It's
Yeah.
gonna do a join to
Hmm.
get the required data.
Okay. Okay, cool. The understanding is correct, but a little different. So Ayan, you mentioned like something, right? What is that 5 seconds?
Yeah, hello Chandu. Yes, Chandu, I'm audible.
Yeah, I can hear you.
Yeah, Chandu, if we set max degree of parallelism is more than like 4 or 5, then SQL Server will execute according to if we are using where class or joins.
Okay.
It will use that all CPUs if it
Okay.
requires.
Okay.
If it not means it will go with the single logical CPU.
How it decides it requires or not?
It's depend on the if you are not using any where class of if you are not using any inner joins or something. If you are going with just for the select query, then it will go for the only one CPU, logical CPU.
Okay. So
Even
now
though if we have 3 to 4 CPUs, it won't take exact time. If it is less than 5 seconds, it will go for the one CPU only. If more than like where class we are using our inner joins, or if we are using, it will consume all 3 CPUs and it will use all 3 CPUs.
now, so I'm using where clause. So doesn't mean that it will not go for parallel.
Yeah, it will go for the no, it will won't go for the parallel.
Why?
Sorry, it will go for the parallel
Why?
because we are using where class.
Okay, fine. So others, anyone? Shay?
I think sometimes it depends on the cost threshold. So
Yeah, it depends on
yeah,
estimated cost.
yeah. So it depends. But in this last statement, it's could because you actually say where ID is less than this is
Whatever value.
1 million.
Equal.
So it means you are meant to the SQL Server is meant to retrieve almost 1 million, like 990 something, it's a lot of information, it's a lot of data. So it might trigger parallelism. Yeah.
Correct. Yeah, that is true. Thanks for that. And the one that you mentioned is completely depends on the cost. cost threshold for parallelism, right? So what does it mean by cost threshold for parallelism? So it checks that what is the individual operator cost during the compilation or during the plan generation, and optimizer understands the individual cost is by default it is 5. So there is no measurement or there is no units for this 5. So it is a 5, right? So if it detects that cost of this operator, cost of this execution is more than 5, by default I'm talking, then go for parallel execution, right? Let's say even if you execute a simple select statement, if it find a difficulty to identify, difficulty to get retrieve the data, if it is taking more than 5, right? The cost is more than 5. Even if it is a simple select statement, go for parallel execution. So that is the thumb rule, right? So it has to validate the cost of that operator or cost of the execution of your query, and based on that it will go for parallel execution, right? So if
More
your
than
cost,
more than 5 cores. You mean
ah,
more than 5 seconds or what?
yeah.
Okay. Okay.
Sorry, what is the question?
Are you talking about more than 5 seconds because you
No.
say more than?
This is not seconds, right? That's what I was talking. So this is there is no units for this cost threshold for parallelism. Suppose if you go here, I will show you. There is no unit. That is just a cost of the individual operator. What is the cost, right? Either it is a 5 or it is a or somewhat, right? So select star from. So don't worry about, so whatever that we are getting here. So I'm just showing you the individual cost, right? So if you see here,
Hmm.
right? So the cost of the operator, like you can consider that, so estimated subtree or estimated subtree basically, right? So the cost of the operator is, so what is the cost of the operator, and based on that cost, so it will go for parallel execution. This is currently a 2, right? There is no units or there is no units for this particular cost, right? It is just a cost of that operator, right? The cost will be defined in the instance level, right? Right click on the instance and properties and advanced, and where you'll see at the bottom. Sorry. Right. So based on this cost, right, then whatever max degree of parallelism that I have, so it will go to execute by the parallel threads, right? So cost threshold is depends, right? So I see that systems where we have more than 50 also. Yeah.
Okay. So let's say the cost threshold of a parallelism here is, we put it for 50.
Okay.
This 5 is by default, right?
Correct.
So what if you not set the threshold for 50?
Mm.
So
Mm.
how the SQL Server will work in that way? Is still going to be the same way if the cost of that query is more than 5, it will
Mm.
go for parallelism, or is there any other mechanism about that?
No. So that's all right. If you
If it's
set
more
it to
than 50.
50, yeah. If you set it to 50, it will wait and run with a serial thread until it reaches to the 50.
Okay.
Yeah. That gives you some situations, right? I will talk that some situation it might be better or some situation is not. So that is what you will have to understand the workload and the issue. So we can tweak these values, either cost threshold for parallelism or max degree of parallelism. So if you don't want every query to go for parallel execution, even if it reaches to the 55, so whatever the cost, then we can increase that cost threshold so that it will wait before even it goes for parallel execution. That is where we'll have to tweak the cost threshold for parallelism value. But yeah, so we all know, right? Parallel execution will definitely gives, so improve performance. Let's say, for example, if your query is running on one CPU, it is taking 10 minutes. And if you split across and two CPUs, then it will be the data distribution or the workload will be distributed among these two, right? So it will be 5 minutes, it will be 5 minutes, right? So the execution would be faster if you're running the threads parallelly and execute on multiple CPUs. But there are downside that we will talk, right? So there are downside also if with the parallelism. Now, what I was talking, so let's say you are executing some query. Select, I'm just taking a simple query, select star from table, right? So I'm taking a simple select statement and it reaches that max degree of parallelism, whatever that we have. So it reaches that max degree of, cost threshold of parallelism 5 by default I use. If it is 5, then what will happen? It requires a multiple threads to execute because it is, parallelism required to execute this query. Then it decides the parallelism is required during the compilation stage only. It identifies requires a parallelism. Now, the parallel threads, how that works, there will be a parent thread. That is what we call it as a thread 0, parent thread, and whereas it will have a child threads. Child thread, right? So you will have one parent thread and you'll have multiple child threads that you have, right? So if you see that, let's say, for example, you have max degree of parallelism set to 4. So if you set max degree of parallelism to 4, can anyone tell me, suppose I have a max degree of parallelism set to 4. Now, if I execute a query, so if I execute a query, so what is the maximum threads it can spawn? Only 4 or can be more?
It can't be more because you already set it to 4.
I set it to 4. So I
Mhm.
set max degree of parallelism to 4. So the number of threads to execute a query would be more than 4 or it is exactly 4.
Exactly 4.
No, I
How?
think it depends on the number of CPU cores you have, right?
Number of what?
Depending on number of CPU cores that you have, right? That's where you're going to set your maximum degree of parallelism to.
So a cost is more, right? You know, whatever the cost we defined, the cost threshold for parallelism, it is more than that, and then only it is going for max. Then it is going for parallel execution. Now the question is, if it goes for parallel execution, we know, right? Like let's say, for example, if you set it to 4, then 4 threads will spawn and execute on 4 CPUs. I have whatever 4 CPUs or 8 CPUs, it doesn't matter, right? So I have 4 max degree parallelism set to 4. Now the question is, if I execute a query and the query maximum it go to 4 threads, it spawn 4 threads to execute, or it can be more than that.
It
Only
can't be
that
more
fourth
than that.
thread.
You did before.
You have to be that fourth thread. When it triggers parallelism, it's going to be using that fourth thread. It's going to be using the fourth thread.
It will go for the 4 and it will complete the execution time within a little span of time.
No. So I'm not talking about the time it takes. I'm asking only whether it takes only 4 or it can be more than that. That is my
It's going to take only that 4.
Exactly 4.
Yes, one parallelism is triggered. Only that 4.
Okay. On what basis it takes 4? It is executing based on the complete query. Okay. So anything else? Someone mentioned like some mixed. I couldn't understand. Like someone said like it is more than 4. Why? How? Or no one said.
Nobody, I don't think anybody said that because you already set that degree of parallelism to 4. So the thread will be running based on the CPU, based on what the CPU you have on your server.
Okay.
Yeah.
Okay.
Based on what you specified.
Yeah.
Okay. That is true, but there is a catch there, right? So if you execute a query, so each query executes based on different operators that we have. So we will talk that later, but just your understanding. So we have here, we consider that as two operators. So each icon, each, here we consider as one operator. So which operates that particular execution. This we call it as an operator, and this we call it as an operator. So if you use that, if you have multiple operators that I have in the execution, right? So that I have in the execution. So the threshold, the max degree of parallelism or parallel execution, I was telling that, right? So each operator will have a dedicated cost of that particular operator, right? So each operator will have a cost. This max degree of parallelism, it all depends on the individual operator, right? So what is it, what I mean, each operator can go up to maximum 4 threads. So if you have 4 operators, then each operator, this can go to 4 threads, this can go to 4 threads, this can go to 4, this can span 4 threads. Total 16 threads can spawn for a single query. If you have more than one operator and each operator cost is more than 5, then each operator can spawn multiple threads to execute. So the answer is, if you define max degree of parallelism 4, and you can have more than, more than 4 threads. It all depends on the number of operators that we have and the cost of each operator, right? Just to answer, just for your information. And if you see that sys.sys processes, and you will find that how many threads it spawned to execute, right? That is the normal misconception. If you query execute, if it's a query, if you're running query, and if we define max degree of parallelism 4, then it can go maximum 4 threads. No, it all depends on the operators that we have. If you have more operators, then each operator can go to the threads which we define, define in the max degree of parallelism. It can be 4 or whatever max degree of parallelism we define, right? So it can go 4, it can go 1, even it can go 1, it can go 4, right? So it all depends on the cost of each operator. Right?
Does that mean that the more complex the query is, the more the cost of operator that is likely to come up in the execution plan?
Exactly, correct.
Wow.
Right.
Got it. Thank
That
you.
is what you see that, so even if you define that max degree of parallelism to 4 or 3 or whatever, more than 1, so that will take you will see, or you will need to notice that high number of threads are spawning to execute that particular thread, particular particular query. It all depends on the complexity of the execution and the operators and the cost of the each operator.
I see.
Thank
So
you.
the
But in
shifting,
the question, in the first question that you were asking, is it going to execute parallel, or it's just like executing on a single thread? The first question that you asked, like select, start from the table.
That's what,
where
no, it
ID,
doesn't matter whatever we have this query, right? So if the cost is 5, or if whatever we define the cost threshold for parallelism, if it reaches, or if it meets that value, then it will go for parallel execution. Even if you have a very complex query, right? You have a complex query and the cost is below 5, right? So complex query, and it gets the data immediately, right? Whatever resources that I have, and it gets the data immediately without even reaching that cost threshold limit, then it go for serial execution and get the data. It all depends on the cost that we define, and the optimizer, while compilation, it identify what would be the cost, estimated cost of this operator, and go for serial or parallel execution. It doesn't matter what query that you are running, either it is a where clause, or defining where, or without defining a where, or even joins, or doesn't matter. So if it reaches that cost, then it go for parallel execution. If not, then serial execution.
Got it. Thank you.
Good. So now I have that child threads, right? So you have that, I'm just taking a typical scenario of multiple threads. It doesn't matter how many threads it spawn. So it can be 4 or 40, doesn't matter. So I'm just taking one simple typical example. I'll remove this everything. So this is the query that I'm executing. Right, so query is select star from table, and the cost is 6, or cost is more than 5. So I'm just defining the cost threshold for parallelism. Cost threshold for parallelism is defined as 5, equal to 5. Now I have a and I have to execute on multiple CPUs, right? I have whatever like CPUs, and it spawn. This is the parent thread 0, and you have the child threads, right? So this parent thread will divide the work, right? So for example, this requires 20 pages to get the data, 20 pages. So then what will happen? These 20 pages will be divided across multiple threads. Like for example, 5 pages, 5 pages data, 5 pages data, 5 pages data, right? So this thread will process and get the data from these 5 pages, and this thread, the other child thread, will process and get the data from the other 5 pages, and this 5 pages, and this 5 pages, right? So likewise, the data will be distributed, and each child thread will process the data and will sync the data to the parent thread, right? So all these will be synced to the parent thread. So all these data will be consolidated and will be synced to the parent thread. So the parent thread will generate the result set, right? For example, this is executing, and this got the result set, and this got the result set, this got the result set, and this has not generated the result set because the thread is slow, or whatever the CPU might be occupied some other process, some other thread, right? This has not generated the result set. In that case, the complete result set is not happened. The result set is not completed. Then all 3 sets has to wait for the other thread to complete, other thread to process the result set, right? So it will keep on checking whether your process is completed or not, right? Parent thread will keep on asking whether your task is completed or not. If one of the thread or one of the task, one of the thread is not completed its execution, the all remaining thread has to wait for this to be available. So until and unless the one of the thread which is in pending is completed, remaining threads will keep waiting on the CPU to get the confirmation from other thread. That is where you see some other performance issues. So now, if it is distributed the workload, the amount of time it's spent, the CPU utilization, everything will be same, right? What does it mean? If these are all waiting on the CPU, nothing else, right? It will not come out of CPU. If the thread is going and running on the parallel execution, and each thread is 100 millisecond CPU, right? Say for example, just a rough measurement, like, and each thread, one thread is 100 milliseconds, then each thread will be distributing with the same amount of CPU cycles, right? If one thread is increasing its time to get the data, the other threads also will increase its CPU time, because all other threads will not go out of CPU until the thread execution is completed, because it is considered as running only, right? If the thread is running, and it is considered as a running query only, because it needs some data to be processed. So that is where you notice high CPU utilization because of CX packet. CX packet or CX consumer is nothing but a thread is waiting for synchronization. The thread is waiting, or parent thread is waiting for the child threads to synchronize and get the result set of that individual threads processing, right? That is what you see, the high CPU utilization or CX packet wait times, right? If one of the thread is lagging behind, the other threads also will be waiting for the execution to be completed, the other thread to be process the result set. Until and unless this thread is completed, the other three threads has to wait and increase the CPU time, right? If that is the case, you will see waiting for CX packet or CX consumer. So both are same. I think starting from 2016, a CX consumer thread is was introduced because of this same logic, right? So let me see if I can show you the parallel execution. So let's start from what. Okay, let it be. It takes some time to get the data. Okay, so CX packet or CX consumer, if the thread is executing parallelly and you see, so one of the thread is lagging behind, so that is where you see the CX packet. I mean, not lagging behind basically. So if the thread is running parallelly, that is what you see CX packet waited. That's it, simple. So whether CX packet is considerable or should we take any action on CX packet, it all depends on the issue that we notice, right? So because of CX packet, we see high CPU utilization, right? Because CPU spikes, CPU will be pegged up or CPU will be, so increasing, CPU utilization would be increasing because all these threads which are spawning and running on the CPU and not allow other threads to run, right? So if that is the case, the CPUs will be increasing. The long running query will be running on multiple threads and executing and taking most of the CPU time.
Yeah, I think Joko.
Yep. Sorry, you have a question or you're asking something?
Yeah, I'd move go.
Meet everybody, please.
Gonna call it really get glitch.
Sorry, I didn't understand. Is that a question or it's your voice is echoing? I couldn't hear you.
Meet everybody. He does.
Oh, he's
just
not,
them.
not
Mute
talking to
them.
us. Okay.
Yeah, no.
Okay. I thought that is a question. Okay. Cool. Okay. Okay. That's fine. Okay. Fine. So that we will see, like I'll spin some query and execute the result set, right? So that is what you see a CX packet. CX packet is basically CX packet or CX consumer is basically if the thread is running parallelly, then we see that it is waiting for the wait type is marked as CX packet so that it is a notification that the query is running parallelly, right? So when this is considerable, right, I was talking, right, if the thread is running parallel execution, if one of the thread is delaying its process, then all other remaining threads would be slow, right? So all other remaining threads will be increasing its CPU time and the total time as well, right? If that is the case, what will happen? If that is the case, then your parallel execution would be slower than serial execution. Suppose let's say you have multiple threads. So if one thread is waiting and remaining 3 threads also waiting. So instead of that, what if I have only one thread, on the only one thread to execute the CPU? That would be much more faster than waiting for other threads to complete, right? In such situations, so based on the query, based on the so issue, maybe we can change that max degree of parallelism to 1 for that particular individual query as a query hint, if that is possible, right? If you notice the same behavior across all, then maybe that is where we will have to come up with so instance level or database level max degree of parallelism settings, right? So you have how many ways that you can set the max degree of parallelism? One is instance level max degree. Second, you have a database level. Third, you have a query level. So query level will precede then other things, other two configuration, like precedence will be first to the query level, next to database level, next to instance level. Let's say, for example, instance level, I have 4, right? So, but database level, I have 8. And this is also starting from 2016, right? If you go here, properties, options, right? If you see here, max degree of parallelism, this is starting from 2016. This configuration has enabled, right? So we have database level configuration as well. And if you set it to query level, you set max degree of parallelism set to 1, maxed of 1, maxed of 8, maxed of 4. So which one will take precedence would be your query level. So this is the first, this is second, this is third precedence, right? So even if you define that instance level as 0, and if you define the database level, a query level, anything specific, then it will take that as a precedence, right? So that is what you can define, either it is a query level or database level or instance level, the max degree of parallelism. It all depends on the workload that we execute, right? So instead of leaving that and keeping that, so increasing in spike in the CPU or any other time execution time, we can set or define the max degree of parallelism set to 1, so that you will have only one thread execute on the CPU. So how to check like whether, so either how many threads it spawned to execute on the CPU, right? So I was unable to show you, but select start from, I'll take some examples and we'll show that that later. Select start from sys processes, where speed equal to 54. Let's take a simple one, anything. And you see here ECID. ECID, this defines how many threads it executes for your query. How many threads is spawned to execute your query, right? So if you can see that 0 to the maximum threads of that particular session. So you will have to identify that ECID. You'll have to, so find ECID and the session ID, right? So if the query is running parallelly, each session will have multiple threads. The session will not be changed. For example, here, if it is for 54 session, then you will see multiple threads for the same session, right? So thread 0, 1, 2, 3. Where you will identify this thread 0, 1, 2, 3, that is where you see here in the ECID. So ECID, you will see that value. If the query is running parallelly, then ECID will tell, ECID column will tell that what is the how many threads it spawned to execute this session 54, right? So in the wait time, you will see wait or last wait type or last wait type, you will see that CX packet or CX consumer, if that is the case, right? So you will have to find ECID and the session to identify how many threads is spawned to execute a specific session. Now, so SOS scheduler yield, right? So we were talking that SOS scheduler yield, so continuously. SOS is a SQL operating system. That is, I was talking, right? SQL Server, we have a separate layer which schedule the threads, right? So now the thread is waiting. So I have the scheduler here. I have a CPU here, SQL OS. I have a CPUs. It can be 1 or 2, whatever it is. So it is a one-to-one mapping, right? So as well as SQL scheduler and the CPU. How to identify scheduler? I told you, right? So you can have select start from sys.dm_os_ schedulers, right? Here you can have whatever CPUs that I have, that we have the visible schedulers, right? So these are all hidden schedulers which are not comes into the picture, but here is the visible schedulers which it maps to individual CPU that I have. I have 4 CPUs and 4 schedulers will be created and executed, right? So one more scheduler, that is your scheduler 64. I mean, that is your node ID or whatever it is, and visible online, and that is only for DAC connection. For example, all schedulers are busy and it is not allowing you to connect. Then you can open a DAC connection to connect to the SQL server to check what exactly is going on. That is another scheduler which is not actually using by the user sessions or user queries, right? This is very dedicated administrative connection. I believe you all know it. SQL operating system, right? So I told you, right? So this SQL operating system, we have to have our own scheduling mechanism. So we have our own list. Either it can be runnable, it can be waiter. Let's say, for example, runnable or waiter. Mostly it is I'm talking only runnable here. So you'll have waiter and so timer, IO, everything. Let's say this is a runnable. Runnable is nothing but it is not waiting for any resources. It is just waiting for CPU to be available. That is what runnable. So when this thread will execute, this thread will execute once it receives an signal from the thread which is currently running on the CPU. As soon as it receives the signal, the thread will go ahead and execute. It will be coming out and it will execute on the CPU, right? Until and unless the thread in the runnable queue receives a signal, it is waiting for SOS scheduler yield. That's what SOS scheduler yield. So SQL operating system waiting for schedule the thread, and it is waiting for the current running thread to be yielded, right? That is what the meaning of SOS scheduler yield. That is just a so my definition. SOS scheduler yield is nothing but SQL operating system has to schedule, and before it's scheduling, it has to wait for the thread which is running on the CPU to be yielded, right? The thread has to be yield. Yield is nothing but a thread which is coming out of CPU, right? It should come out of CPU. It has to yield, right? So until the thread is yielded, the thread in the runnable queue has to wait, right? So until the thread is yielded, the SQL operating system will not schedule the thread to run on the CPU, right? So until the thread is yielded, then you will see the SOS scheduler yield. So when it is noticeable, so when you see that high signal wait time, that what we discussed, and that is what you will have to find what is the signal. I'll close this. Right. So you'll have to identify that what is the highest signal wait time. So how much time it is waiting for signal, right? So to receive by the thread which is currently running. So then it depends on that particular value to see if the thread is long running or not. Again, all these goes to long running queries, right? So CX packet, if thread is currently executing and running for longer, or so waiting for so most of the time on the CPU, waiting for CX packet, then it is kind of so query that you'll have to investigate. And SOA scheduler yield a thread or query is running on the CPU longer and it is not yielded and not allow other thread to run on the CPU. So again, it is a long running query that will have to check. Right. So these are the two wait types that we see. And thread pool. Let's say I was talking earlier, right? When scheduling, how scheduling works. A thread pool is pool of threads. When a task is created, the task will be assigned to a thread from that thread pool and will be executing on the CPU. Let's say you have a busy system. Suppose if you have a busy system and your max workers limit has reached, or you don't have any available threads in the thread pool to take any of your tasks. If that is the case, what will happen? You will see thread exhaustion situation, and the threads will you will not have any threads to take care of any of the tasks that you can consider. Let's say even a simple connection, even a simple connection from SSMS, that also requires one thread to execute. Even if you don't have enough threads available, then you would not be able to establish a SQL connection as well, right? If that is the case, what you will do? So if you don't have threads, then let me take it here. You have a busy system and you have around 2 CPUs. Let's consider that. And these 2 CPUs are busy enough. And if all threads are exhausted, because all threads are taken, its own task and waiting in the queues, and thread pool is empty. I don't have anything in the thread pool. SQL requires thread to be available in the thread pool to open a connection. We don't have, and I'm unable to connect from SSMS also, right? I'm unable to connect because I don't have any thread to execute on the CPU. My entire CPU is busy. I don't have any thread to be available. See, if that is the case, what max you can do, you can connect using the DAC. You can connect to the SQL server using DAC connection and query and identify what are all running on the SQL. So what are all running on the CPU, right? So either it can be a huge blocking or it can be a huge parallel execution. Because of that, all threads are exhausted, or it can be anything, right? So you will have to connect to the DAC connection and identify what exactly is running on the CPU. One thing, just a moment. Current wait down, wait time, the system current wait, high signal wait time. Okay, right. So I was talking about signal wait time, right? So this query will tell like what is the total signal wait time and what is the percentage of signal wait time, right? So if you see that total wait time, if the signal wait time is significant portion of the total wait time, it means that tasks are waiting a relatively long time to resume execution after resource that they waiting for become wait. I mean, so resources are available and in the runnable queue, the thread is in the runnable queue and waiting for most time to run on the CPU. So that is what we call it as signal wait time that we already discussed. Total wait time is equal to signal wait time plus resource wait time. that is thread waiting for some resources, right? And example, SOS scheduler yield. If you notice that high signal wait time, right? High signal wait time, the signal wait time is 10, 15 minutes, 15, so I think this is seconds, sorry, percentage. So 15% is or 15 to 20%, whatever it is, and it is considered as significant or more signal wait time that you'll have to identify. That I have just calculated based on signal wait time and wait time that we have, right? So this is the percentage calculation. So you can identify how much time a thread is currently waiting in the runnable queue and waiting for signal to be given by the thread which is currently running, right? So that is how you will have to identify whether SOS scheduler is noticeable or any action is required to take, right? And if the threads are full, right? So threads are, if you don't have any threads available in the thread pool, then that case, then you'll have to connect to the DAC and you'll have to identify what are all currently executing. But here in our discussion, it's just to talk about the wait type, right? So wait type is a thread pool. If the threads are not available, if available threads are not, if the threads are not available to take any of the task to perform, then it is waiting for thread pool. Lock, we all know. So if the any incompatible lock, right? So you are executing some select statement, right? And at the same time, you are doing some update or you are doing some delete. Then it requires an exclusive lock on the table or on the resource or on the row that we are executing. Then it will be locked by other session, right? For example, begin plan update adventure works person set first name equal to 100. Sorry, first name equal to anything ABC. Select star from if I execute this, and it will be blocked. That is what you see here. Select star from sys processes where speed greater than 50. So usually the sessions, right, whatever speed that we have less than 50 or mostly are not mostly less than 50 are for system threads or background threads. If it is more than 50 is considered as a user sessions, but it is not always. You can still see threads which are more than 50 also dedicate background or system threads. But the thumb rule to identify is if it is less than 50 sessions are for system or background threads. If it is more than, it is you can consider or investigate if the thread is more than 50, right? So if you execute this, you will have only the user sessions and few sleeping so background threads also, right? So you don't need to worry about background threads. You'll have to think, you'll have to check. Even sleeping sessions also an issue, right? I was talking earlier. So even sleeping session also can be contributed. We will talk that later, but for now, understand here the LCK, right? So this is waiting. Okay, this is waiting for some lock to be available on this, so whatever resource. This is a tab lock, right? It is completely a table level lock. That is what you see, that instance shared lock in like whatever. So that is a tab lock. It is waiting for the overall the complete table. It is locking to get the result set, because I'm not using or I'm not defining any so any of the where clause. So it has to lock the entire table. We will talk that locks later, but here, if it is a lock and it is waiting for some lock to be released, or it is waiting for some resources to acquire a lock and proceed its execution. Page IO latch or latch, page latch, whatever you can consider. So page IO latch is basically, what does it mean by latch? I'll tell you what is latch. Latch is, you are doing some transaction. Let's say, for example, so if you're doing some transaction, uh, you're executing some query, select start from table. This is a transactional level. This is a logical, right? So transactional level, we are acquiring a lock, right? Logical. And at the same time, the physical protection also required at the page level. So, right. So we are doing a transactional level, right? So the table level we are locking, for example, and this is a transactional, or this is a logical where we are locking the table. And the physical, the pages also should be locked, right? So how the pages will be locked? With the help of latch. Latch is nothing but a physical protection of your page, right? I have a physical page, 8 KB page, that will be latched by execution. Whatever whatever query that you are executing, that has to be latched. Let's see if I can show you that. Select start from sys dot latch stats. If I execute, okay, fine. So it is just, so you see here, like it may be waiting request count, or select star from sys.dm underscore voice underscore waiting task, where right. So I don't have any latches, but I'll take some examples and will show you. But here, if it is a latch, the physical protection of the page, right? So I am protecting my page. So if I want to protect, so it has to acquire a latch. So it is same as lock. Lock is a transactional and logical protection of the table or data, whereas latch is to protect your physical page, right? So protect your data page physically, right? So that is the physical level protection that we are holding. So when you see that page IO latch, what will happen? The page IO latch or page latch, you need a page, right? So you're executing select star from whatever, and we require a page. If the page is available, page is in memory, that is your data cache, that acquires a, until the operation is completed, that acquires a page latch. Page latch, either it can be exclusive or it can be update, it can be page sh, that is shared, right? Whatever operation that we perform, so it will be waiting for page latch if the page is available in the memory. If page is not available in the memory, then it has to get the page from the disk, right? Then it will be holding a page IO latch. Page IO latch is nothing but until and unless the page is received from the data file and keep it in the memory, that will be waiting for page IO latch, right? Page IO latch is nothing but a page is not available in the memory, and then we'll have to get the page from the disk, that is data file. So then you'll have to investigate if there is any storage issue or any memory issue that we will discuss, right? So just understanding the wait type, right? If it is a page IO latch, so page is not available in the memory, so we need to get the page from the disk. That is your data file. So what is write log? So write log wait type. So I was talking, right? So whenever you perform any operations, so write ahead logging, what it does, it will be writing into the transaction log file before even writing into the data file, right? So that is what write ahead logging. Now, so whenever we perform any modifications, this is your tlog file, tlog, this is your memory, right? Whatever. So we are performing some query, right? So some update. So as soon as we perform update, what will happen? You'll have a internal structure where it stores that transaction information. That is your log cache, right? So this is what I was talking right earlier when we were talking about the architecture and all, and log cache. Whenever you do any modification, it will write into the log cache, and log cache, it will be flush this data to the transaction log file periodically. So how that? If the transaction is committed or if the log cache is full, then it will be writing continuously to the transaction log file, right? So if it is writing continuously or if it is writing, then it will be waiting on write log. If the data is writing from the log cache to the transaction log file, and during that time, it will be waiting on the write log wait tab, right? So if you see that higher write log wait tabs, then you will have to check why we are keep writing into the transaction log file. That is where you might be executing very aggressive, like, so either it is a simple so simple transaction which is closing frequently, right? It is not a batch, it is just a so simple update query you are executing and committing the complete transaction. Each transaction you are committing, so instead of committing in a batch, each transaction you are committing. If that is the case, each transaction has to write immediately to the transaction log file, because as soon as we commit the transaction, it will go ahead and write into the transactional log file, right? So we can delay these writes, right? We can delay these writes by enabling delayed durability. Starting from 2014, we have a feature called delayed durability. Delayed durability. If you enable this delayed durability, even if the transaction is committed, it will not flush the transaction to the log file. Even if the transaction is committed, that will not flash the transactional data to the transaction log file until and unless the log cache is full. So what is the downside of it by enabling delayed durability? Can anyone? What is the downside of using delayed durability? Delayed durability is as soon as the commit completes, it will not flush the transaction to the log file. It will wait for log cache to be full, then only send to the transaction log file.
What if that is a disaster during that time? That will there not be a data loss?
That is the downside of that. Suppose if any restart happen or anything, this is the log cache is in the memory, right? So if any restart happens, so whatever data which is there in the memory, so it will be vanished, right? So you will not, it will be deleted. So you will not have that, you cannot recover the data which is there in the memory, that will be gone. So that is the downside. So you will have that the data loss, right? Whatever time committed transaction, you will have that data loss.
There may be a data loss.
Yes. So that is the downside of that. So that is the reason before even enabling this, and you'll have to think whether it is required or it is just, so based on workload that if we can tune the query itself, right? Instead of committing the complete transaction, you can use that batch, right? You can use the batch and you can commit at the end of the batch. What will happen if the restart happen? Let's say, for example, batch started at 10 o'clock. Right. So if the batch started at 10 o'clock and so this is sorry. Batch started at 10 o'clock and 10:40 the restart happened and the batch has not completed or committed. Then the entire transaction will go for rollback. This is what your ACID properties, right? Either all or none, right? Atomicity, either the transaction is completed or none. But what will happen to this 40 minutes rollback? That is completely, it's completely gone, right? Even if you have multiple transactions here, that the entire transaction data will go for rollback. So instead of that, maybe you can, if you're a developer or if you're an application team or development team, they can set a save transaction in between. So if I go, yeah. So if you roll back, instead of rollbacking to the entire to the start of the transaction, if you use the save transaction until this point, the transaction will be committed and the rollback would happen up to this save transaction that we define in the query, individual query level. Right. So yeah, if your developer or if your application team is working on, maybe they can build a logic to save the transaction instead of rolling back the entire transaction to the all the way to the so starting of the transaction. That can be done. That is another so way that you can avoid a high excessive write log operation that we have. Any questions?
Hello, Chando.
Hmm.
In what situation we will go perform this one delayed?
Delay transaction, that's what, right? So delay durability, if you see that excessive writes into the transaction log file, and because of that, if the IO is excessive, right? If the storage is slow, I mean, if the storage is slow, or if you have a high number of writes to be written to the transaction log file and you see that excessive IO operations, then your queries will be slow because it has to write into the transaction log file, right? Before it marked as, so final commit and all. And in that case, your transaction will be slower because your IO is waiting for, I mean, your disk is very busy because you are doing a excessive IO operations. If that is the case, you will have to consider delay durability as an option, but that is not always solution, because if you restart the SQL instance, whatever data which is there in the memory will be deleted.
Okay,
This
so we
option you
should
can
not,
consider. Yeah,
we
you
should
should not.
not enable this one. Huh? Will DBA will be enable this one, or it will be come from the development team?
It's a DBA activity, DBA option. Yep.
Okay,
It's a
okay. From
database
where we need
option
to enable?
from the database option. Let me see, delete your ability.
You pass it. Go up.
Here.
Yeah.
No. So where is that?
It's up.
Delayed durability. Yeah.
Yeah. It's disabled.
Yes, by default it is disabled. That's what, right? It all depends on the workload. That's what Microsoft has given this option, but it is disabled in state, right? So that all depends on the workload that we have. So if that is required, and we'll have to enable that delay durability to, utilize, I mean, to enable that feature. So you'll have to explicitly enable. So it is not that forcefully that we are enabling. No. So it is not enabled for all the instances. It is all depends on.
Jando, I have a question here. So
Yeah.
I used to see this wait type sometimes. So my question here is, in what percentage or in what number will I consider that wait type as a problem?
You mean write log?
Yes, the right log.
So write log, for example, so if you're asking the percentage, right? So percentage, I might not tell, right? Even if the way like if you doing an excessive IO operations, excessive commit, or so you have that huge OLTP servers, and if you are doing a so high intensive write operations, then definitely you will see that so write log wait time. So does it mean that actually an issue? No. So it all depends on the issue that you are facing, right? Because of this, and you notice that the queries are slower down. The queries are you notice some slowness in your execution or queries. In that case, whatever percentage that we have, so we'll have to consider that it is high, right? Suppose if you are asking a percentage, maybe the same logic, right? Even 15-20% if you consider, then it is typically so kind of higher in higher to consider. But it all depends on what workload that we are executing and what is the query that you are running and how much time it is taking to execute. For example, IO operations, if it is a excessive so IO that you are doing, then it leads to your query performance as well, because writing into the transaction log is a synchronous way, right? So queries has to wait for the transaction to be written, then it is marked as commit, right? Before it is commit, then the log file the data has to be written to the transaction log file. If that is delaying, if you see that a high write log or excessive IO, right, then it is, you will see some latency in your queries, right? So but if you see a high latency of your transactions or your queries, and you see that high write log, that is what you will have to notice. Either it can be a 10%, 20%, doesn't matter. And if you see that queries are running slow and you see that high wait types with the write log, then that is what we notice. So we'll have to check why it is waiting for so write log wait type. But write log again, write log wait type is expected to see, because it has to write into the transaction log file, and during the write operation it will be waiting on write log wait type. So but if you notice that waiting most of the time, either it is 20% or 15% item, then at least we'll have to look into that what exactly is going on. But that is not something that just see that 15% and you'll have to turn on this delayed durability. No, because the transaction might be very huge and it has to keep writing into the transaction log file.
Chando, how can we know that there is a write log is happening?
Sorry,
How can we know that there is a write log is happening?
it all wait types, right? If you see here sys.dm underscore wait task and waiting task, and you will see that wait type as write log. This one.
Okay, okay, sir.
So this is one of the wait type. That's it.
So at that time we need to wait up.
You'll have to wait. You cannot take any action, right? If it is writing into the transaction log file, you'll have to wait that.
Okay, okay, sir.
Yeah.
Thank
So until and unless you see some performance issues on the server or the execution or of any of your queries, so maybe we'll have to so leave that so wait test without any action on that particular waits.
Okay, thank you.
Sure. Right. So any questions? Okay, so we'll give you so high level, because we will discuss all these three detail, like in always on one of the performance scenarios we'll take and we'll discuss, and these two are related to memory. One of you already mentioned, right? HDR sync commit. So what it is, right? So HDR sync commit. So in always on, you have a primary, you have a secondary. primary and secondary, right? So if primary, you are doing some any DML operations, right? If primary, you are doing some operation, DML query, insert, update, delete, whatever it is, it has to send to the secondary replica, right? Let's say it is a synchronous, right? So, but sending data is doesn't matter either it is sync or async, but let's say it is a synchronous commit in always on. So I believe that you all worked on always on. I'm just using this synchronous and asynchronous terminology. I assume that you know always on concepts, right? So primary and secondary, and you have a synchronous commit. And whenever a DML operation you perform, primary will send a send that so to the secondary. Can you tell me how the data will be sent to the secondary in always on? Whatever DML operation, let's say you are using insert query or update. So how the data will be sent to the secondary? Okay, so I'll mention that we don't have much time.
It
So
will first to go into the secondary. and it
how,
will
in
come
what
back.
form? In what form it will send to the secondary? The entire transaction will be sent to the secondary. Okay, so it will be sending log blocks. So each transaction log file you will have transaction log file is further divided into multiple VLFs, that is your virtual log files, and each virtual log file is further divided into multiple transactional log blocks, and each block you will have that individual transaction information, right? So VLF is further divided into one or more the log blocks. So always on, the data synchronization from primary to secondary will be sending an each individual log block. This log block it will take and it will send to the secondary. Like it will be taking secondary, it will send to second log block and it will send, right? The log block it will be sending from primary to secondary, and secondary will receive the log block and harden that log block. What do you mean by hardening? Hardening is nothing but writing the log block information into the transaction log file, right? Hardening is nothing but writing the data, writing the transaction log block information into the transaction log file. That is what hardening, right? That there also you will see that write log. So write log is nothing but writing into the transaction log file, right? Here also it receives the log block and writing into the transaction log file. On the secondary, we call it as a write hardening. And once it is hardened the log block, then it sends an acknowledgement to the primary stating that I have received the log block and hardened into the transaction log file. Once primary receives that confirmation or acknowledgement, then the transaction will be committed on the primary. The transaction is marked as commit, right? Until and unless the primary receives this confirmation or acknowledgement, it will be waiting on HDR sync commit. HDR sync commit is waiting for commit. Primary is waiting an acknowledgement from the secondary to commit the transaction, right? So waiting for acknowledgement from the secondary stating that the hardening is completed so that the transaction is marked as commit on the primary replica. So until then it is waiting for resource until that it is waiting for HDR sync commit waits, right? How to troubleshoot, how to investigate, that we will discuss the detail in the always on section. So we'll have so different ways you can identify and resolve that HDR sync commit, but that is not a straightforward. It all depends on the workload that we have. Resource semaphore query compile, right? So what is that? You execute any query, right? So if you execute any query that requires some amount of memory, right? Any query that needs some amount of memory. So a memory utilization of your query in a different stages, right? So one stage is to compile the query, right? Compilation, it requires some amount of memory. Execution, it requires some amount of memory, and storing that plan requires some amount of memory. The memory required for your execution is divided into 3 stages. One stage is to compile the query, requires some amount of memory. Once compilation is completed, the query has to execute. The query execution requires some amount of memory. Then the plan, the query plan has to be stored in the memory. That also needs some memory in the that also needs some memory to save your execution plan, right? These 3 memory areas, memory consumptions for your execution, for your query life cycle, right? Now, query compilation required some amount of memory, right? If the memory is required, I mean, if the query is complex and if it needs more memory to be compiled, and SQL doesn't have that that memory to be available, then it is waiting for resource semaphore query compile. If the query requires more memory or query requires some memory and SQL doesn't have that memory to be available, then the query will be waiting for resource semaphore query compile until and unless the memory is available. So how the memory would be available? Some other query is running and taking some memory. That query is completed and release the memory, right? The query memory is a temporary basis, right? As soon as the compile is completed, the memory will be released. As soon as the query execution is completed, the memory will be released to the SQL server. But the planned memory will not be released until and unless we remove the plans from the planned cache, right? Here, the resource semaphore query compile, the compilation of your query requires memory which SQL doesn't have. Then it has to wait for this memory to be available to go ahead and compile the query. Until then, you will see the query is waiting for resource semaphore query compile. So that is a compilation memory. Resource semaphore memory, resource semaphore waited. Resource semaphore is the execution of your query. This one to compile, and I was talking that execution also we require memory. That memory is for resource semaphore. The query requires some memory. SQL doesn't have that requires memory to execute your query. Why we need memory to execute, right? Why we need memory to compile? So memory execution required because you are doing some sorting or you are doing some internal joins. We will talk joins later, but you are doing some sort operation, for example, or you are doing some re-indexing, rebuild index. If you notice that rebuild index sort on tempdb, if you don't sort on tempdb, it will be going on memory and then it will go for so some further thing, right? So you will have that sorting. The sort happens in the memory, right? Temporary work area. It creates a temporary workplace and it sorts the data in the memory itself, right? That is what it requires memory to perform that internal operations of your execution, right? So if you have more number of records, you will have more memory for that particular execution or particular query. So if you have a query and waiting for some memory to be available to execute, then it will be waiting on resource semaphore. As soon as another query which is consuming memory is completed, the memory will be released and the next in the queue will be picked up and go ahead and execute the query, right? Take the memory and execute the query. This is resource semaphore. Resource semaphore is the memory, the query requires memory to execute, that is to grant. You will have that resource semaphore query so you have few DMVs that we will talk in the memory so that you will understand. So one DMV is memory grants. So let's start from sys dot dm underscore query exec query memory grant. So you will find what are all queries which are waiting for resource semaphore or waiting for most memory that we will talk. So but all these wait tags that you see here or whatever wait tabs that we have, All these you will get from the sys.dm exec request or sys.sys processes, anything. But most majority, I look sys.sys processes, sys.dm exec request. Starting from 2016, I think exec session wait tabs, right? Earlier we have that sys.dm underscore OS wait tabs. That is the entire instance level. And if you want to identify individual session wait tabs, you can find using sys.dm underscore exec session wait tabs, right? So we already discussed this sys.dm underscore OS schedulers. That is the individual schedulers we have, right? These are all the common wait types that we have. Any questions so far on any of these wait types that we have?
Chandu,
Hmm.
then how we need to troubleshoot? I mean, like this query is taking more time and taking resources.
Hmm.
So we need to take that and we need to send to the development team, right?
Correct. So you'll have to identify the query. First thing, like either it is waiting for some resources or the query is running, right? So if the query is waiting for some resources, even developer team cannot do anything, right? If the query is waiting for some resources, you will have to identify what it is waiting for, and we'll have to check what it is waiting. For example, it is waiting for some lock. And that is waiting for some lock. Some other query is running, and because of that, this query is waiting for some other lock, waiting for some lock, right? So you'll have to identify that header, or so identify the root of the lock or root of the problem. So you'll have to either investigate or we'll have to provide to the developer team that this query is running slow, and you'll have to take it.
So how need to identify that query with the SPID?
We will talk that in the query tuning.
Okay.
I'll show you. I'll show you that, so what is the session ID and how to identify that if the query is running longer or not. But just for your information, we have DMVs, right? Select
Yes.
start from sys.dm exec request. I think I have shown you. Request, for example, where session ID equal to 61, for example. And you have that something called CPU time and elapsed time.
Elapsed time.
So elapsed time, it tells like what is the total duration of the execution, whereas CPU time is total time spent on the CPU. If you see that total elapsed time is more or significantly more, then we consider that
No
the
issue.
query is that the query is waiting. So if the CPU time is more, the query is running. If the total elapsed time is more, the query is waiting for some resources. That is what you will have to identify. That we will talk that.
Okay. Thank you, sir.
Cool. And this is just a high level, right? So everything is relevant, right? Related. If the CPU is CPU high, then it can be a signal, it can be parallelism, it can be memory, it can be excessive recompilations or bad execution, whatever it is, right? So everything is relevant in your SQL, in your server. So if your CPU is high, it can be anything. It can be a memory issue because of memory CPU spike, high CPU because of IO. There is a high CPU utilization because of parallel execution. Then there is a CPU, anything, right? If it is memory because of so some CPU utilization, you have a high excessive memory utilization by the SQL Server or by the execution of your queries or anything. All are relevant and related each other, right? So we will talk in detail, like so further discussion. Then based on that, we'll go forward from there, right? So any questions? I'll stop here.
Have you shared the GitHub
I will share.
account yet? Or
Yes,
files?
I will share.
Okay, thank you.
Yeah.
No, just checking, no rush.
Not now, so but I'll share that GitHub location.
Okay.
Sure.
The
Yeah.
recordings
Thank
also, Chandu.
Recordings you're not getting?
No, last class I didn't get.
Okay, maybe. Okay, I'll talk to. So you the others, like you got the recording or you haven't?
I don't have. Last 2 classes I have recorded.
Okay.
Yeah, I'm not getting the recording as well. Maybe my email was wrong or something.
I'll check. I'll talk to Sharmak and we'll, so share the recordings then.
The recording was in the YouTube.
That will be
So-
stored in the so cloud.
The last two recording is in YouTube. You can see it there.
Yes, he posts everything on YouTube.
Right.
Yeah. SOS University, you have to subscribe and make sure that you are signed into your YouTube account with the email address that you gave him.
No. So that is,
So
I
that
think
way you'll
he
have access
just
to everything.
no,
Huh?
yeah, that he just posted, but that is not actual. So the recordings that we are giving to giving to you guys, right? That is just so demo classes that he posted. But whatever recordings that we are doing in a daily basis, that will be shared to you guys separately through your
Yeah,
email.
but I understand. But if if you give him an email, for example, he has my Gmail account. If I signed in to my YouTube with that Gmail account, I can have all the recordings, even the ones that are not in public.
Correct.
That's what I'm saying.
Yeah, that is true. That is true. So as soon as he shared that, so and you will receive an email with whatever, so the link that he uploaded, Google Drive or OneDrive. So you will get an email and you will have to log in and you'll access that. But I'll talk to him, like if he has already shared or, so to the people, like so that you will get that recordings.
Sometimes he may not post it right away. So.
Sure, I'll check and I'll let you know. I'll check and I'll ask him to upload that. And I assume that he has all so email IDs of yours.
Question: are you gonna have those performance tuning script available?
Yeah, that's what, right? So I'll upload and I'll have that, so in the GitHub repo, and I'll share that all scripts to you, so for your information. And I'll also share this, so PPT, so once this is completed, not immediately, but yeah, so I'll share both.
Are you going to, oops, sorry, interrupt. Are you going to cover the performance tuning for the always on?
Yes, I'll cover. Maybe I'll cover high level scenarios, right? So we have basically log send queue and ready queue. So I'll cover that as well. Yeah.
Thank you.
Excuse me, I have a question here.
Yes.
I will share a request. So all these DMV that we are using, is it possible for you to be helping us to pilot in a OneNote and give us a brief note of what those DMV is doing, just for our daily uses?
So you're asking that you need DMVs, or you're asking how the DMVs get the data?
No, like, we are using a lot of DMV in this class now. So I was thinking maybe you are putting it somewhere. Maybe you want to share those things with
Yeah,
us.
definitely. Sure, definitely. I got your point.
All
So
those
you need
DMV that we are using.
all
the DMV
like
that we are using in the class right now. Are you going to share all the DMV?
Yeah, I'll share that. Yes, correct. Not only this, right? So I have certain DMVs which are daily we should use or we use. So I'll share that in a maybe Word or whatever, like OneNote Word or something. Then I'll upload that as well.
And you're gonna describe a little bit that this one, this is what you use it for. This is what you use it for.
Yes.
Okay.
Yeah, maybe not detail, like at least a high level in a 1 or 2 lines. Then I'll mention that.
Okay.
Cool. Right. I'll stop recording here.
Thank you. Have a great weekend.
Right. Thank you. Have a good night. Bye.